Hi everyone. In this chapter we've been dealing with polynomials and we've had to do some dividing and some multiplying, and sometimes it's gotten kind of hairy, lots of division and lots of multiplying. So today I'm going to show you a binomial theorem, and it is a way to expand a binomial. So binomial is a two-term polynomial, like this one has two terms. To expand it, in other words, to multiply it by itself. So you can either square it, but that's too easy, that's foiling. You could cube it, you could still do that. But what if I asked you to do something like that? A plus b to the fifth power. That doesn't mean a to the power of 5 plus b to the power of 5. It means a plus b times a plus b times a plus b times a plus b times a plus b, 5 times total. So the first two you would FOIL, then you would take that answer and multiply it by the third a plus b, then you would take that and multiply that by a plus b, and that would be kind of a headache. So I'm going to show you the binomial theorem, which is a shorthand pattern that you can follow to expand any binomial raised to any degree. So this pattern is the way to do it. It seems a little bit kind of complicated, but if you just follow the steps step by step, you can have even a complicated binomial like 3x plus 2y or something raised to the sixth power, and just follow those steps and figure out what in the world the entire polynomial would be, rather than multiplying it out again and again and again. So it all starts with Pascal's triangle. Okay, here is Pascal's triangle. So Pascal obviously is the guy who came up with this, the mathematician who came up with this type of pattern. If you Googled Pascal's triangle and found all the incredible properties that are embedded in this, it's amazing. It would be maybe an extra credit report or something. That's an idea, because there's so much that you can do with Pascal's triangle, and I'm just going to barely touch the surface of this today. But we have basically a triangular pattern. These are rows across. This very first one on the top is row 0. So this is the first row, the second row, third row, fourth row, fifth row, sixth row, seventh row, eighth row, and you could keep going on and on and on. And the way they're created, he starts with 1 and then 1 and 1, and each row is the sum of the numbers above it. So he starts with 1, and then 1 plus 1 is 2, and then the other one. And then here's 1, and 1 plus 2 is 3, and 2 plus 1 is 3, and then 1. And do you see how this works? Here's 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then 1. So there's always ones on the ends. And until we get down here, like 1, and then 1 plus 6 is 7, and 6 plus 15 is 21. This is 35, and you get that pattern going all the way across. So you need to know which row that you're dealing with, and these numbers are important and very, very handy. I have some copies of Pascal's triangle that I will make available to you, and you can keep in your notes because it's a great reference, or you can print one off the internet if you want, or you can write your own following this pattern, but you will be using Pascal's triangle. Let me show you how. Let's say I'm asked to find the binomial expansion of a plus b to the power of 6. So a plus b times a plus b times a plus b, 6 times altogether. Okay, what I would start with is the 6th row of Pascal's triangle, or this row right here. Those are going to be my coefficients in front of each term in my polynomial in my answer. My first term in my answer will have a coefficient of 1. My second term of my answer will have a coefficient of 6. The next one, 15. The next one, 20, 15, 6, and 1. So that's the first step in your answer. So I've isolated the 6th row of Pascal's triangle because that's the one that we're going to use for our coefficients. And now we are going to look at this binomial. And the first term is a, the second term is b. It doesn't get any simpler than this. This is why we're doing it this way. And each term in our answer is going to have a total degree of 6. So the first term will be this first number, 1. My first term in my binomial, which is a, that's going to be a to the power of 6. So a to the power of 6, and my second term, b to the power of 0. 6 plus 0 is 6. That's my first term. Second term, so plus. My second term will have this coefficient of 6. Now my a is going to decrease by 1. So my first term is going to be a to the 6th. My next one's a to the 5th, then a to the 4th, then a to the 3rd, then a squared, then single a, then a to the 0. My second term is going to do the opposite. It starts at 0, then to the first power, then second degree, third degree, fourth, fifth, and finally 6th. That's how we work our way across. So my first term, a was 6, b was 0. My second term, a will be 5, b will be 1. All right, plus my next term, which will be this coefficient, 15. And now my a will be 4 and my b will be 2. Do you see how these are going down and my second term's going up? Next, plus the next term, which is 20. And now they're both going to be to the 3rd. A to the 3rd, b to the 3rd. Plus the next term, I don't want to run out of room. Well, I have room for one more. 15. Now a is going down, b is going up. A squared b to the 4th. Plus, because I've run out of room, my next coefficient of 6, a to the 1, b to the 5. See how they still always add up to 6? And then my last term has a coefficient of 1, a to the 0, b to the 6. And I just went ahead and wrote everything down. These are all the terms of my binomial. Can you imagine multiplying a plus b so many times until you get this many terms? It's crazy. Now what you're going to go back and let's simplify each term one at a time. So the first term, this is just 1. B to the power, anything to the power of 0 is also 1. So this just simplifies to be a to the 6th. My first term is a to the 6th. Then this term is 6 plus positive 6, a to the 5th, and just b. You don't have to write a power of 1, just b, it's just 1b. Plus 15, a 4th, b squared, not bad. Plus 20, a cubed, b cubed. Plus 15, a squared, b to the 4th. Plus 6, a, b to the 5th. And then plus b to the power of 6. And that is your answer. So that seemed complicated, way easier than multiplying a plus b 6 times. Okay, let's say it's not so simple. It's not just a plus b. Let's say we have this binomial, 3x minus 2, and we are going to raise it to the power of 5. 3x minus 2 times 3x minus 2, ugh. So we are going to use our binomial expansion, that binomial theorem, that binomial expansion, to come up with our polynomial answer, all right? Our first term, last time it was a, this time it's 3x. Our second term, which last time was positive b, this time is negative 2. The last time it was to the power of 6, so we used the 6th row in Pascal's triangle for our coefficients. This one's to the power of 5, so we're going to use the 5th row of Pascal's triangle for our coefficients. So let's start there. The 5th row of Pascal's triangle is 1, 5, 10, 10, 5, 1. All right, so each step, first the coefficient, then the first term, then the second term. So let's get started. First one is 1. Then we have 3x to the power of 5. Do you notice I put it in parentheses because 3x to the power of 5, that means the 3 and the x raised to the power of 5, right? The next one is negative 2 negative 2 raised to the power of 0. I know that's just 1, but I just really want to be careful because I'm not used to doing this. I don't want to make shortcuts, all right? Second term, plus positive 5 times 3x, and now this goes down 1 to the power of 4, and my negative 2 is to the power of 1. Plus 10, you're always adding these. Doesn't mean they're always going to stay positive, but when we're setting it up, we're adding. Plus 10, so 3x, and now it's to the power of 3, and our negative 2 is to the power of 2. And our next term is the second 10, plus 10, 3x to the power of 2, and negative 2 to the power of 3. Right, then the next one is plus 5. Our 3x now is to the power of 1, and our negative 2 is to the power of 4. And then our last term is a plus 1, 3x to the power of 0, and negative 2 to the power of 5. Okay, those are all the terms not simplified. So now we're going to go back and take each term one at a time and simplify, and be careful. Make sure you understand all the rules for powers. Okay, our first term, this is 1. Anything to the power of 0 is 1. So this is 3x to the power of 5. And 3 to the power of 5 is 243. There's our first term. 243x to the 5th. Okay, now let's look at our next term. We have 5 times and 3x to the power of 4. So 3 to the power of 4 is 81 times 81, x to the power of 4 times negative 2. So now we simplify the numbers. 5 times 81 times negative 2 is negative, that's negative 10 times 81, negative 810. So this is negative 810 x to the 4th. Now we're on our next term. We have 10 times 3 cubed, which is 27, x to the power of 3, and negative 2 squared is positive 4, right? Negative 2 times negative 2. So now we're multiplying 10 times 27 times 4. 27 times 4 is 108. So I think that's 1,080, and this is positive. 1,080 x cubed. I'm going to double check that. Okay, I got that right. So that was this term here. So now we're at this term. So that's 10. 3x squared is 9x squared times 9x squared. And negative 2 to the power of 3 is negative 8. So now we have 10 times 9 times negative 8. Well, this is negative 72 times 10, so that's negative 720, and it's x squared. All right, do you see how this makes sense? Our x's are decreasing. Okay, now we are at this one. So now we have 5 times just 3x, and negative 2 to the power of 4 is positive 16. So 5 times 3 times 16. 5 times 16 is 80. I think that's 240x, I think. And it's positive. Positive 240x. I'll double check myself. And now I'm on my last term finally. This is 1 times 1. So it's basically just negative 2 to the power of 5. 2, 4, 8, 16. That's negative 32. And I'm done. Notice this was a binomial to the power of 5. So it should have 6 terms. 1, 2, 3, 4, 5, 6. And that is how you do it. Take your time, one term at a time. Notice in this binomial, this second term was negative, so sure enough, my signs alternated. Do you see that? This is the binomial expansion of 3x minus 2 to the power of 5. That is what this section is about. This is your lesson check. I'm going to have you try this, work it through. I want you to give me what's the binomial expansion of 2x minus 3 to the power of 4. And to help you, I gave you the row in Pascal's triangle. The fourth row in Pascal's triangle is 1, 4, 6, 4, 1. So those are going to be your initial leading coefficients. 2x minus 3, so you just saw me walk through that, to the power of 4. See how well you do. Fortunately, it's only 4. And see how well you do following that pattern, and bring it in and we'll look it over for this section. And that's it. Have fun with this if you can. Take your time, it's worth it. And I will see you guys next time.